The next part of our notes are graphing these, so this time we'll actually be accurate with our graphs, unlike my little sketches from earlier. Sketches are fine for getting an idea of what's going on, but being able to actually graph, as always, is important to be precise. We have an absolute value for the first part when we're less than 0, which would be, looks like we have a shift and a shift. The plus 3 is a shift left 3, the minus 1 is a shift down 1, so left 3, down 1 is going to be the vertex of our absolute value graph. Absolute value graphs are just a line going in the positive direction with a slope of 1 and also going in the negative direction with a slope of -1, looking like this, touching at each corner. It says don't include the 0, so put a little circle at the 0 for x. For the second part of the function, 2x minus 5, that is a line with a slope of 2, a y-intercept of -5, so just bring your first point down 5, put a dot, because we are including 0 at this one. The slope is 2, so we can just go up by 2 every single space and connect that with a line. And here's our piecewise function. The domain from left to right. From the left side, we are following the absolute value graph. It goes down, it goes right. We don't have any gaps over here in the orange. There is a jump from the y-intercept at 2 to the y-intercept down at -5. If you look at those two spots though, even though one of them is an open circle, the bottom one is closed. So that is not a gap in the domain, because even though we're not using this number here, when we plug in 0 for x, we are using this number down here, and then we just continue from there. So the domain for this function is all the real numbers. The range, let's just check from bottom to top. It looks like we don't go any lower than this point from the red y-intercept, which is at -5. So -5 is the lowest y we're going to have on our graph, and then after that it goes up and it goes up, and it'll be all the numbers greater than -5. The lowest y was -5, and we do include that number, and we will go up to infinity from there, so that's a range. Just to keep the domain and range similar, I'm going to add y is an element of in front of that interval. And then discontinuity, whenever I said the word jump between here and here, that is a type of discontinuity. Whenever your graph has an open circle at one spot and then it jumps down or jumps up, but uses the same x, then that is a type of discontinuity. Jump, discontinuity. At x equals 0. Okay, for this next example, we're going to graph it again. We're going to do the domain, the range, and the discontinuities. With this x, since there's no power, it's just going to be a regular line, but there's a negative sign in front, so this means slope is -1. The -4 is the y-intercept. So we'll start this one at -4, and it's going to have a negative slope from there, but we're not actually going to use that number because it says we're using the x's that are less than -3. So if we did follow this graph backwards though, we could just trace it using that negative slope to look like this. But since our x is here, must be less than -3, less than or equal to. Then let me just back that line up, put a dot here, and I'll use my eraser to take it back. Once you get to the -3, it wants you to use the other part of the function. the negative 1/2 x squared, so that would be an upside down parabola. Since I've done ones like this in the past, I know that this is centered at the origin, but to help you out with this -3, I'll show you with a table. X, y equals negative 1/2 x squared. And since we're using the x's greater than -3 for this orange one, then I'll pick -3 just to see where it's at. I'll use -2, -1, and 0. Okay, and 1. So we're going to take the x, square it, and then do half of that. -1/2, -3 squared. The 3 squared makes 9. Half of 9 is 4.5. Make it a -4.5. We have -1/2, -2 squared. Inside the parentheses, that -2 squared makes a 4. Half of that's 2, and then turn it negative. -1/2, -1 squared. That's gonna the inside the parentheses will turn into a 1. The 1/2 will turn it into a half, and then make it negative. Let me go ahead and graph these first few dots. -3, -4.5. At this spot, we don't include it, but we just open it up with a circle. After that spot, we have -2, -2. Since this one isn't at the boundary, we can include that number. -1, -1/2. 0 is going to make 0. 1 is -1/2, 1 squared, which is -1/2. And then right here we can already see the symmetry. That means whenever we're plugging in these numbers, we're getting the same thing out of it that we already saw in the past. On the right side from 0 is just going to be a mirror image of the left side, which means I can copy those points that I already did. 2 with -2 and 3 with -4.5. And then since I don't have a boundary over here, I can just keep on extending. Now for the domain from left to right. Left, our red line goes forever to the left, so we have a -infinity. It goes to the -3 and includes the -3. After the -3, it picks back up on the orange at exactly -3. So there are no gaps. It was included. And then we just go on forever to the right. So -infinity, +infinity, with the parentheses around those infinities. For the range, let's see how low the graph goes. You always start with the minimum first. It goes down on the orange side forever. It's going to go up. The orange one makes it to 0. So if we just match that 0 to the red graph also includes 0, so there are no gaps there. And then it goes up and up to infinity. So from the bottom was -infinity, and then there were no gaps. It goes to infinity. Discontinuity would be if there were any jumps or holes, and we do have a jump from the red graph to the orange graph at -3 for x. Okay, this one could be annoying, but let's see if it is or isn't. The domain. From the left, it goes from -infinity. We got an arrow pointing forever to the left. We have a asymptote at -3, so from -infinity until -3. Since there's an asymptote, we don't touch the -3. We pick up right after it though. Starting with -3, right after the asymptote, we do include the 1 with the red graph. The purple one does not include the 1, which is important because if they both included the 1, then that would make these not a function anymore. So everything's okay. We include it with the red, we don't include it with the purple, and then we pick up right after that going to the right. So from -3, we have no gaps to infinity. For the range, with the red graph, since it goes the lowest, I'll start there. The red graph goes to -infinity. It goes up from there. The red one doesn't include 0, but if you follow that line across, the 0 is used by the purple graph, so that's not a real gap. The purple graph goes up to infinity, and so does the red one, and they overlap up here, so we don't have any gaps in the range. We do have a couple discontinuities. For one thing, we got the jump one, so I'll start with that because that's what we had in the last couple examples. Jump discontinuity is whenever you're included on one part of the graph, but you're not included on the other, and you just jump from one function to the other at a certain x value. We have a jump at x equals 1, and we do have one more discontinuity. Discontinuities are in the domain, and the domain does not include this number because one side of the graph is going down to infinity at x equals -3. The other side of the graph is going up to positive infinity. So we call this, the jump here is that we went from -infinity and then we jumped right after that to positive infinity. So we call that an infinite discontinuity. And that infinite discontinuity happened at x equals -3. If you want more explanations about discontinuities, I can link that also in the Schoology. Out of these next two functions, I'll do the square root one since you have the least amount of practice with that. We got 3 functions, so I'll use 3 different colors. First one is an easy one. When we're less than -1 for x, we want to be at 7. So at -1 for x, 1, 2, 3, 4, 5, 6, 7. We want to be up at 7. This one does not include the 7, but that's the y when we're less than -1 for x. Once you get there, we have an x cubed minus 1. So let's just plug in the first part of that into a table. If you plug in -1 and then cube it, that will give you back -1. If you subtract one more number 1, you'll get -2. So at -1, we jump to -2, and that's when it gets included. So let's just plug in a couple more numbers until we get to 2. 0 cubed minus 1 is -1. 1 cubed minus 1 equals 0. 2 cubed minus 1 equals 7. So I need to go with -1, a 0, and 2 goes with 7. So we're back up here. Checking that, we do include that, so I can just connect this with the curve and include those endpoints. Finally, we're at the square root function. Let me change the color of that. Okay, we got a negative square root 2x plus 1. So I'm going to use my calculator for that. The reason it'll be annoying is because of that 2 that's multiplying. Normally square roots of numbers aren't that bad to do in your head, but multiplying things by 2 and then square rooting, it just messes up the scale. Okay, we got that. We're supposed to pick this one up at 2. Then let's zoom in on the Desmos. 2 for x goes with -1 for y. 2 for x, -1 for y. Just to approximate, 4 for x goes with almost -2, but not. So 4 with almost -2. And then we can just continue that pattern in the negative direction. Domain from left goes until -1, but the -1 is included down here in the green. From the -1, it goes to the right and goes to x equals 2. 2 is included on the green, which means I need to fix the purple one. The purple one should have an open circle right there. And then from the 2, it goes forever to the right. So -infinity, no gaps, +infinity. No gaps for the x's. The gap will happen with the discontinuities. We're going to have 2 jumps. We're going to have 1 jump at x equals -1 and a second jump at x equals 2. We jump from the orange to the green, then we jump from the green to the purple. Range. The purple one goes the lowest. It's going to go to -infinity. The purple does overlap with the green, so we don't have any holes in the range. Then the green overlaps with the orange, but the orange doesn't get any higher than 7, so our max is going to be 7. So on the right side of the range, include that 7. On the left side of the range for the minimum, we go down to -infinity, and we close that parentheses. Okay, that's today's notes. Hopefully it was helpful with the domains and ranges. If you think these videos are as good as the other person's YouTube videos, let me know in class. Thank you.